Hi everyone. Here's a video on how to conduct a 2x2 between groups Anova in R. First, I'll make a new notebook. And I'll clear all of the template code out of there. And I'll call this my 2x2 between groups Anova notebook. So I think it's a good habit whenever you're creating a notebook in R to start by installing all the packages you're going to need. Now, sometimes what will happen is you'll get partway through your notebook and you'll realize you need a new package, and you need to install a new package. And what I recommend in that situation is that you actually go back up to the top of your document and install the package there. So I'm going to call this first section installing packages. And I'm going to insert a chunk of R code. Now, my advice when you're coding in R is never to just rely on or to assume that you should have memorized every little piece of syntax and every bit of code. And instead, what I recommend you do is that you have a notebook of common tasks you perform in R, so you can refer to that notebook and just copy the code you've written from there into your new notebook. In this case, for this class, I have created a website with a lot of common R tasks that you can refer to. And so this is the address for this website. And you can see it has a number of different tools or categories of tasks you can perform in R. In this case, we want to perform an Anova in R, in particular a type 3 sum of squares Anova in R. And I'm going to be copying most of the code from this notebook for this demonstration. So the first package we're going to need in this video is a package that teaches R how to import SPSS files. And so I'll paste that code there. What this code does is, first it checks if Haven is already installed. If it is, it loads it. And Haven is the name of the package that will import the SPSS files for us. If Haven is not already installed, Haven is installed. So this code actually installs Haven, and then this line loads Haven after it's been installed. And so by having the if statement around the install packages line, that ensures that we aren't installing Haven if we don't need to. But also, if we pass our code on to someone new and they need to install Haven, well, it will install for them the first time, no problem. We'll also use the tidyverse. This is a really useful package for cleaning up your data, reshaping your data, recoding some of the variables in your data, things like that. And we'll also need this package called affix, which I think is has to do with analyzing factorial experiments or something like that. And for us, the key is it makes it really easy to do type 3 sum of squares. And I think for now, that's all we'll need to install. Maybe later I'll remember something else and we can come back and install it. So I'll just press play on this. It looks like those packages are all installed. I'll press play one more time to see if it disappears those warnings. That's good. Okay. And then we have our packages. The next thing we need to do is import our data. So I'm going to have a section called import data. I'm going to create an R chunk. I'm going to save our data into a variable called dataset. I'm going to use a function from the Haven package to read an SAV or an SPSS file from one of my OSF projects. So this is just the address of an OSF or of a SPSS file I have on an OSS project. And so this should download. Oh, I got this one line wrong. I think this should download, and then we'll have access to our data sets. So nothing happened there, but there visually happened there. But there are a couple ways to confirm that the variable dataset now contains our data. One of them is clicking on the Environment tab, and we can see that, oh, there's now a variable called dataset. It's a table or a data frame. It has 715 rows, and there's 6 variables. And if I go down to the console and I type this command, view dataset, I can actually explore this data set just like I would be able to in SPSS or Excel or any other spreadsheet program. So I think this is a really useful feature of RStudio, being able to just look at my data sets like this. And so what I see in this data set is there are 6 variables. One of them is the subject ID. And there's 3 independent variables, or between groups variables, I should say. Between groups, independent variables. So this is a study in which participants received training to reduce bias, and there were 2 types of it. One that was focused on attitudes and one that was focused on identification. And within each type of bias, there was an experimental condition that was designed to reduce bias, and then a control condition that was designed just to maintain bias. The final 2 columns refer to IAT score. So race DFEB refers to the attitude IAT score, and IDEN DFEB refers to the identity IAT score. So race DFEB is a measure of implicit prejudice against Black people, and IDEN DFEB is a measure of implicit identification with Black people. And this variable, IAT order, simply describes which IAT came first. Was it the implicit prejudice IAT or the implicit identification IAT? So we've got 3 between groups variables, and we've got 2 dependent variables. So I'm going to go back to our notebook now, and I'm going to make a section called clean the data. I'm going to insert a chunk. So one thing that's good about this data set already is that honestly, I've already cleaned it up mostly, right? So there aren't any extraneous variables. All of these variables mean what they mean. We don't have to recode anything, so that's very helpful. But there's a possibility that some subjects might be duplicated in this data file. And of course, I say that knowing that it's true. But how can you tell? Do you have to scroll through? I mean, one helpful way is to just sort the data file, and then ones that are duplicated would be right beside each other. But still, you have to visually go through it. You could make mistakes. I mean, there's 600 people in this data set. It can take a while to scroll through very carefully. It doesn't matter whether you're in R, or SPSS, or Excel. There's going to be some difficult things here. Okay, so luckily, R has a function that can identify duplicate rows for you. and it's part of the tidyverse. So let me show you how it works. We're going to start with dataset, and we're going to pipe dataset into the function called distinct. And if we look back at our dataset, the subject ID variable is called subject. So we're going to say check subject for being distinct. In fact, what I want you to do is not to return just the rows that are distinct, just return me all the other ones, right? So I only want rows that are distinct. And then I want you to assign that new dataset to a dataset called dataset.unique. All right, so we're starting with dataset. We're removing all the duplicate rows, and we're saving that in a new variable called dataset.unique. I'm going to press play. Visually, nothing should happen on this side, but over here in the environment tab, we now see that dataset.unique has 714 observations because there was one duplicate row. So that can be a useful tool when you're trying to clean your data. All right, let's now perform the 2x2 between groups Anova. So I'll insert a new R chunk, and we're going to use the AOV underscore easy function of the affix package. So I'm going to start by creating a new variable. I'm going to call it dataset.unique.aov for analysis of variance. And I'm going to assign to it the results of the AOV, so analysis of variance underscore easy function. All right, so we're here. We've got this AOV underscore easy package that I learned about, through Googling what's the proper way to conduct an ANOVA in R. First, we need to tell Easy Anova the name of our subject variable, no problem, subject. Then we tell Easy Anova what our dependent variable is. In this case, I'm going to just choose the implicit prejudice variable. Then we tell Easy Anova what's the table with our data set. In this case, it'll be dataset.unique. And now we tell Easy Anova what our between groups independent variables are, and we just list them. So I'm going to list train type and train type and EC. So that's the focus of the training. Is it focused on attitudes or identification? And the goal of the training is the goal to reduce bias or to maintain bias. And when I press play, undefined column selected. So what's happened here, common mistake, I've misspelled one of my variables. You can always just check dataset, what's the exact spelling of these variables? In this case, I've misspelled training type by adding the E. And again, we get some information, but we don't know what happened here. On the right, a new variable was created though, dataset.unique.aov. It has 5 elements. And if we want to look at it, what we can do is we can just type that variable into the code chunk, and RStudio will interpret that as print out the contents of this variable. So I'll press play again, and now we can see our Anova table. And so this 2x2 Anova tells us 3 pieces of information. It tells us, is the main effect of training type significant? And it is not. Then it tells us, is the main effect of training goal significant? and it is. And then it tells us, is the interaction between training type and training goal significant? And it is not. So in other words, the only thing that really matters in this study, it doesn't matter what type of training you underwent. All that matters is, was the goal of the training to reduce bias or not? But what we don't know at this point is, well, did the reduce bias training reduce prejudice? Or maybe it backfired. Like, we don't know at this point. We just know that there's a significant difference. We don't know the direction of that difference. And so we've got to write a little bit of code to find out the means, the marginal means related to training to reduce bias versus training to maintain bias. So I'm going to make a section called calculate means and standard deviations. And I'm going to start with the dataset.unique, because that's our raw data that has all the individual responses for each participant. And I'm going to pipe that into a function called group by. Now, if you're familiar with SPSS, group by is similar to the split by function. So you're going to split your file in SPSS. In R, in the tidyverse, you're going to group your file. So we're going to group by, because I'm interested in the main effect of training goal, I'm going to group by the variable that I'm interested in. So I'm going to group by EC and then pipe this new grouped table or data set to a function called summarize. And as I'm sure you're guessing now, summarize is going to do the work of creating the means and standard deviation. So I'm going to make a variable called mean, and that will be the result of the mean of our dependent variable. I'm going to make a variable called SD for standard deviation, and that will be the result of calculating the standard deviation of our dependent variable. And then I'm going to save that to a variable called, let's call it training goal descriptives. All right, and so when I press play, there are no errors, but also nothing visual happens. But in the environment, I can see a new variable was created. And if I want to have that variable outputted to my screen, I can just write training goal descriptives, and R will output it. There we go. So we can see when the value of training goal is 0, the mean is about 0.15, and when the value of training goal is 1, the mean is about 0.23. And looking at my notes for this project, I can see that 0 for the training goal variable refers to the reduce bias condition, and I can see that 1 refers to the maintain bias condition. I guess I would also make a note to myself that actually the control condition, it makes more sense for the control condition to be 0 and the experimental condition to be 1. But on the other hand, that's why we have notes about our data sets. Okay. So we can say now when we look at the Anova table, we see that there's a significant main effect of training goal, and it reflects the fact that participants that were trained to reduce bias had less implicit prejudice than participants trained to maintain bias.